The environmental industry, a partnership of science and engineering, business and government, working on society's most challenging technical problems. To educate the public about this important industry, the Air and Waste Management Association presents the Environmental Management Team, a video series about people and technology and the search for environmental solutions. In this first program, we look at how new ideas and technologies are changing the way cities and towns manage one of their costliest problems, solid waste.
In the early 80s, the method of waste handling was simply to landfill waste. And there was not much concern at that time about the designs of the landfills. Many of them were unlined. Very few had leachate collection systems, and they were in effect old holes in the ground into which waste was put. By the mid-80s, then, the state of Minnesota was directed by the state legislature to stop landfilling waste as our major method of waste disposal.
The problem we had is that in mid-87, our local landfill closed, and our costs just literally skyrocketed. They went from $25 a ton for disposal, our tipping fee, to over $100 a ton. So there was literally overnight a four-fold increase in our disposal costs.
Pushed by landfill closures, the high-density city of Newark, New Jersey, and the 47 cities and towns that make up Hennepin County, Minnesota, were among the first U.S. communities to adopt large-scale integrated solid waste management. The integrated approach is based on a hierarchy of solutions, beginning with efforts to reduce volume and toxicity. This is followed by programs to reuse, recycle, and compost. Most of the remaining material is converted to energy, and only a very small amount of residue ends up at the landfill. How solid waste is managed varies around the world, even from city to city within the same country. But the concept of integrated waste management can be applied anywhere, helping communities to reduce waste and pollution, move away from old bury-it-all or burn-it-all solutions, and save money. There is no single answer, however. The integrated approach offers a range of options, and each community must assemble a system to meet its own specific needs.
You take samples of the waste and look at what's really there. How much are they really generating? And of that, what are the commodities that are in that waste stream? Then you can begin to look at what are the existing facilities a community has, what are the markets for these materials, the commodities really, which are in the waste stream, and start to figure out what would be the best mix of approaches for the community to address the waste stream in the pieces that they have. And one of the things you evaluate when you're doing that is how much is all this going to cost, how elaborate a system can you do, how much the community is willing to step up and do, and what kinds of facilities you need to get this accomplished.
We estimate that we could probably save an additional $3 million a year through further educating the public on the importance of reducing the amount they're throwing away. And the way we save is that for every ton less that the consumers throw out, that's 1 ton less that we have to collect, it's 1 ton less that has to be processed, and it's 1 less ton that has to be disposed of.
The amount of municipal solid waste generated around the world is growing rapidly. In the U.S., it went from 88 million tons a year in 1960 to 180 million tons in 1988, and is projected to reach 216 million tons of waste in the year 2000. Fueled in large part by a worldwide explosion of population, excess packaging and throwaway products, this increase has more than economic costs. Environmental costs are skyrocketing, from waste disposal itself, natural resource depletion, and pollutants released by unnecessary raw material extraction, manufacturing, and transportation. Lowering these costs depends to a great extent on our ability to reduce waste. In industrialized countries, this means changing wasteful habits. In developing countries, it often means not acquiring those habits in the first place. In either case, waste prevention is an area where individuals have a big impact, but it's the least well-developed waste management component. To change this, municipalities have a variety of strategies to choose from. Public environmental education is a good first step. Other strategies include charging by the can or bag for trash collection, providing incentives to product repair, rental and resale businesses, and encouraging industry to both increase product durability and minimize disposable products, packaging, and its use of toxic compounds. Governments are also discovering that they can have a direct impact on reducing waste through their own purchasing and product maintenance decisions.
What we need to do to improve the analysis of what we are purchasing and what happens to it is review in each major purchasing decision the content of the materials being purchased, including whether there is any toxic content that then will require special handling at the point of disposal. We need to review whether or not the product includes recycled content. If it's fabric, if it's roofing, if it's siding, it should contain a percentage of recycled material in that product when we are buying that new product. Additionally, we should be looking at the life cycle cost and handling method of that product, whatever it is.
The waste prevention strategies of private companies, small and large, also play a critical role in reducing the municipal waste stream. One company taking a hard look at its environmental costs is 3M. Their Pollution Prevention Pays program, or 3P, has served as a model for the private and public sector and has found new profits in waste prevention.
No question that it's more expensive to handle the waste once you've produced it. The object of most 3P programs is not to produce the waste in the first place, and that has other ramifications too. Generally it improves the quality of your product, the yield in your process goes up, reducing your manufacturing costs. There are a lot of side benefits to preventing waste. Whatever you seem to do to improve your approach to the environmental issue also seems to help the economics of your manufacturing process. So that's what I mean when I say things, economics and the environment are really merging in this day and age.
The cost of our citywide recycling program is roughly $1.5 million a year. Taking into account our avoided disposal cost, we're breaking even in our curbside efforts. But because of our other recycling activities, like our composting operation, like the fact that we're recycling our concrete and asphalt and a lot of our demolition material, our actual avoided disposal costs are more in the area of $6 million. So in a way, you can almost say that we're making money through our recycling efforts.
Successful large-scale recycling programs like Newark's and Hennepin Counties are dependent on many interrelated components. First, there must be a commitment by municipal leaders to make it work. Then the organizations that collect, process, and market the materials, whether public or private, have to work efficiently. And probably most important of all, the public has to cooperate, which calls for effective, ongoing education and simple, reliable, accessible collection systems. Since the early 1980s, the number of materials collected in municipal recycling programs has steadily grown to include as many as 30 items. A trend-setting program in Hennepin County collects problem and hazardous waste for either recycling or safe disposal, keeping pollutants away from waste-to-energy plants and municipal landfills.
The county has two permanent facilities which really combine reuse, recycling, and special handling of consumer wastes. One of them contains a Goodwill collection site inside so that a person could come in and bring materials for reuse that they'd identified in their home, as well as their problem materials and household hazardous waste. And these items are taken at no charge, and the county program does pay for whatever handling is necessary.
In addition to municipal drop-off centers, recyclable items can be taken out of the waste stream in a number of other ways. There are privately operated buyback centers that pay people for their recyclable items and are particularly important at bringing scavengers and the poor into the formal economy. There are processing facilities, like this one in San Marcos, California, that separate recyclables directly from mixed solid waste. Then there is the most common option, curbside collection. After collection, recyclables that are already separated can be processed directly into new products. In the case of mixed or commingled materials, however, they first go to a materials recycling facility, or MRF, where they are separated and processed for sale. These facilities are designed to reliably provide hundreds, even thousands of tons of high-quality raw materials to manufacturers every day, making them a critical component in many municipal recycling programs.
We look at ourselves as being in the commodity business, the industrial commodity business. And that means we're not competing with other recyclers necessarily, although of course we are. We're really competing with raw materials. Our glass competes with sand, soda, and limestone, and that combination for a ton of glass may be in the range of $60 to $70 a ton. That's what we're competing with. We have reduced the residue to about 1.5% of what comes in. And in New York City, we will guarantee a 3% residue level. But that's because we have developed processes and procedures and recirculation systems to continually remove as much material as is humanly possible that has a market value.
But as the systems for collection and processing have steadily matured, markets for recycled materials have lagged behind.
We still need the markets to reuse those materials, and they're starting to happen, particularly in some areas like newspaper, for example, slower in other areas. Right now, I feel like we're trying to take all these materials out of the waste stream and stuff them through a keyhole, and I'm just waiting for somebody to open that door.
Composting can handle up to 75% of the waste stream in the United States. There are some supermarkets and food factories we've dealt with that after we put in a good recycling program for their metal and their glass and then take their compostables, they're generating maybe 2–3% waste. That's all made possible by composting. Composting is not a panacea. It won't take care of everything, but as any one single category in recycling, it definitely has the lion's share.
Composting is simply the natural decomposition of organic material. It can be done on a small scale in a backyard or farm, or on a large scale, where it is already common for managing yard wastes. But it is not limited to leaves and grass clippings. Any organic component of the waste stream will decompose, and so composting is becoming an increasingly important part of integrated solid waste management. In New Jersey, American Soil Incorporated took the same simple, inexpensive equipment and techniques used in their yard waste composting operation and began an innovative program to compost clean, source-separated food and paper materials from the food industry. The highly fertile end product is then sold to a wide range of customers, from commercial farmers to backyard gardeners.
The only increased difficulty with when you bring in food and paper materials is you have to pay a little more attention to managing it. Just as if you brought in a lot of grass clippings and let them sit, you'd have a tremendous odor problem if you didn't keep them aerated. And when you bring in that food and paper, you've got to grind it up, make sure that it's aerated, make sure that it heats up well so you don't have any seagull problems and that sort of thing. What I'm hoping is 10 years from now, people will not think it'd be that unusual at all and just say, oh, food and paper materials, we compost them naturally.
A number of municipalities also compost mixed solid waste, either by itself or in co-composting operations with sewage sludge. These operations permit composting of a larger portion of the waste stream, but require more complex and expensive technology. Many also have difficulty separating out pollutants, yielding compost with restricted uses. An example of a system that overcomes this separation problem is the rotary vessel technology of Bedminster Bioconversion Corporation.
The advantages of our process begin with the fact that we can take two regulated waste streams, garbage, municipal solid waste, sewage sludge, and convert them into compost that can be freely distributed into horticultural and agricultural applications. We don't have fragments of metal and plastics and things ground up into it. The conventional technologies grind and shred the materials. They try to separate out, but they can't separate all of them out. Because ours is a totally natural process and we screen off the non-biodegradables, we eliminate that problem. We rely on Mother Nature to do the separation. We let the microbes do it.
Based on that study that you did of the waste stream initially, you're trying to get all of the materials that you can segregate from the waste stream, each commodity, to its highest and best use. But there will always be an organic portion which is not separable and would be perfectly happy to go to a waste-to-energy facility. And frankly, I think you can design them and operate them to be an environmentally conscious neighbor.
Although waste-to-energy plants are expensive, they are important to many integrated waste management programs. They can burn and produce power from any municipal waste stream, even after recyclables and compostable organics have been separated out. They are most often used in metropolitan areas where land is at a premium, including industrialized areas of the developing world. Both Newark and Hennepin County rely heavily on waste-to-energy.
25 to 30% of our solid waste goes to a waste-to-energy facility where it's converted to electricity, and from the ash, we're recovering the metal. And we're also looking at ash reuse potential.
We have long-term contracts to send waste to 2 different electricity plants. And currently those plants generate enough electricity to serve 58,000 homes a year. We have one mass burn plant which receives 1,000 tons a day of the county's waste, and it generates enough electricity to serve 40,000 homes in a year. And the second plant that we use is a refuse-derived fuel plant, which makes a fuel. The process there is a little different in that there is some separation on the line as this fuel is created.
Of the 2 basic types of waste-to-energy technologies, mass burn plants, which do not process the waste, are by far the most numerous. Specific plant designs vary, but each is fitted with sophisticated combustion and pollution control equipment, along with highly flexible operational systems.
It's a very heterogeneous waste. It varies. So the equipment has to be designed to combust it cleanly and to control the emissions to very low levels of a varying waste stream. So it's inherently complex. In a utility, you specify what kind of coal you're going to burn very carefully. You specify what kind of fuel oil you purchase. You have control over it. With a waste plant, you take whatever comes. In our case, after recycling. We automate as far as we can. We give the operator the tools. We use computer controls today and have for years. But you still need a skilled operator to tie it all together.
That critical link between operation and design has led to mass burn plants that are producing power at a lower environmental cost than ever before.
Today, the waste-to-energy facilities are actually cleaner from the standpoint of particulates and SO2, sulfur dioxide, and nitrogen oxides than a coal-fired utility plant, and in some cases cleaner than a heavy oil-fired plant. On the contrary, the other side of the story is that we have some heavy metals that the coal-fired plants don't have, and that's why we have baghouses, very efficient filters.
In contrast to mass burn technology, refuse-derived fuel is the product of a sorting system that separates the waste into light and heavy fractions.
The RDF process basically ends up with a fuel that's mainly the components of newspaper, paper products, plastics, and some of your lighter weight fuel such as wood. So if you ripped up some papers and plastics into a pile, you'd pretty much have what we call our refuse-derived fuel.
For Northern States Power in Minnesota, these fuels are then burned in old, refitted coal boilers that had become uneconomical to operate. The fraction that isn't burned consists of metals and glass that are recycled and a residue that goes either to a compost facility for further processing or to a landfill. It also consists of many materials containing hazardous metals, including batteries.
batteries should not be in the waste stream, but the truth of the matter is they are. By separating the lightweight from the heavyweight material, we can get away from a lot of those problems. And it does make a better fuel. So I think there's a good future for RDF out there. I think it's a good idea to remove those contaminants for the fuel before it's actually put into a fire, a boiler.
Landfills are the basic component of a waste management system. No matter how much you recycle, divert, or reduce, there will always be some material that has to get disposed.
But with advances in design, construction, and pollution control equipment, today's landfills bear little resemblance to those built even a few years ago. They are carefully sited and highly engineered. To protect the groundwater, they have multiple liner systems, leachate collection and treatment systems, and leak detection systems. They are completed in cells that are capped with another impervious liner system. For air pollution control and safety, gases are monitored, pumped out and cleaned, and when possible, used for energy. And after the entire landfill is closed and capped, it is monitored for leaks for 30 years. Nevertheless, hazards do persist, and so for many communities, the landfill's role has changed dramatically in less than a decade, from 100% to a component of a larger plan.
47% of the waste stream in our county is now recycled and composted, and we're certainly very proud of that number. The goal would be not to landfill any waste which has not been processed. 2% of the waste stream is still landfilled as raw waste, that is before anything's been done to it, and that still leaves us with 17% in the form of ash and residue that does have to be landfilled.
By turning away from bury-it-all or burn-it-all solutions of the past, municipalities all over the world are beginning to bring their solid waste under control. And in doing so, they are reducing pollution and saving money. They have done it by prioritizing their management according to a hierarchy of components: waste prevention, recycling, composting, waste to energy, and landfilling, to create an integrated plan. There is no single answer.
Recycling in and of itself is not an answer. Source reduction in and of itself is not an answer. Landfilling in and of itself is not the answer, nor is waste to energy, nor is a processing facility to convert mixed refuse to compost. There is no one answer. What we have to do is learn to generate less. We have to learn to utilize our resources more wisely. We need to recycle more. And then what's left, we have to deal with rationally. There is no one answer, and what we have to do is learn to wisen up and use our resources in a correct, proper manner.